the product. There are various chemical reactions that happen. The chemical reactions with epoxides, the chemical reactions with carbon multiple bonds like alkene, like C triple bond N. So you would always form the addition product. Remember, it is always the addition product that is formed. For epoxides, it is a ring opening reaction where the epoxide opens up to form a primary alcohol. There are other reactions which are reactions with nitriles, reaction with esters, reaction with alkenes, reaction with carbon dioxides, and various other substrates to form the products. There is an important reaction which is the reaction with aryl halides and heterocyclic compounds. A very important category of organolithium chemical properties is the reaction with aryl halides and heterocyclic compounds. So let us see what is this reaction. Reaction with heterocyclic compounds and with aryl halides. So let us see, if I have phenyl lithium and I react with chloromethyl. So I say I have phenyl lithium. So I have C6H5Li and I react it So if I have phenyl lithium and I react it with chloromethylene, I form alpha phenyl plus beta phenyl methylene as the product. Alpha phenyl methylene and beta phenyl methylene. So if I have phenyl lithium reacting with chloromethyl, the products formed are alpha phenyl methylene and beta phenyl methylene. Now this reaction is called as the addition-elimination reaction. This reaction is called as the addition-elimination reaction. Addition-elimination, ikattha. Addition-elimination reaction. So this reaction is an example of addition-elimination reaction, and the mechanism involves an intermediate. The mechanism involves an intermediate called as nephthine. I repeat again, the reaction is typical to compounds which contain organolithium, which contain a carbon lithium bond. We have not seen such reaction in a Grignard reagent. So this is an example of an addition-elimination reaction where we take the phenyl lithium, react it with chloromethyl. The products formed are alpha phenyl naphthalene and beta phenyl naphthalene. This is an example of addition-elimination, and the mechanism involves an intermediate called as the nephthine. So intermediate is called as the nephthine. So what is normally said is that the intermediate nephthine undergoes addition and forms both the products alpha and beta. So I think this is all you need to know about the reactions which involve heterocyclic compounds as well as which involve the aryl halide. So you must know only this typical example because this is an important example of the organolithium compounds. There are reactions with alpha beta unsaturated compounds as well. The reaction with alpha beta unsaturated compounds forms 1,2 addition products. I repeat again, like we saw in the Grignard reagent, where there was a competing 1,2 and 1,4 addition, but here organolithium compounds only undergo 1,2 addition. So there is no addition across the carbon-carbon double bond. There is addition only across the carbon double bond oxygen. Why? Because alpha beta unsaturated compounds contain both the double bonds. They contain a carbon oxygen double bond and a carbon carbon double bond. We saw it in the Grignard reactions, unusual reactivity, where it formed two kinds of Michael addition products, 1,2 and 1,4. Unusually, it was the 1,4 which was formed as a major product, and 1,2 was formed as a minor product. But not in this case where we take organolithium. So you can see the shortcoming of the Grignard reagent, the shortcoming that I wanted to prepare the 1,2 as a major product, but I did not form. The shortcoming of that Grignard, I can use it, or I can, if the Grignard is not giving me the desired product, I can use different I can use an organolithium compound. I can, instead of using an organomagnesium compound, I can use a different organometallic compound like the organolithium, where the desired product, which is 1,2 addition. 1,2 is a desired addition. I do not want the 1,4. So 1,2 addition, which is a desired addition, will happen if I take organolithium compound, which was not happening when I took organomagnesium compound or the Grignard reagent. So I think if you prepare the Grignard reagent well, organolithium compounds would be automatically prepared. So you will not find many problems. So Grignard reagent reactions are more, organolithium are relatively less. So with this, I think we have finished with the organolithium compounds as well. Organolithium compounds, the reactions are same, almost similar reactions, but a little more cleaner reactions, except for this addition elimination reaction which was happening to form the nephthine intermediate. Otherwise, there is no different reaction, which is, or there are lesser reaction for organolithium and more reaction for the Grignard reagent. So that is why I told you, if you prepare the Grignard reagent well, automatically organolithium and organozinc would be prepared for you.